Okay, so when we think of connective tissues, we have to think of it like a jello mold. Did you know that there's a jello museum in Leroy, New York? Moving on. When you make a jello mold like this one, with the fruits suspended in the jello, we can make a crude but useful analogy to connective tissues. All of our connective tissues have cells. And we're familiar with cells and their nuclei from looking at things like simple cuboidal cells with the nucleus right in the center. The cells in connective tissue they're various, and we can have things like mast cells, fibroblasts, osteocytes, all cells that we will slowly get to know. But this is like a jello mold here with different kinds of fruits in it. The fruits are like these specialized cells suspended in the gelatin. But what's in the gelatin? If you've ever made a jello packet, you know that it's just water and jello. The jello mix is really just soluble proteins, like horse hoof. Just kidding. Actually, I'm not. But these proteins, they suck up the water and they harden into a gelatin. This is the same thing as the goo in which your specialized cells are suspended in connective tissues. Aside from the specialized cells in a connective tissue, which that is one of the three main components in any connective tissue, aside from the cells, there are proteins like the proteins in gelatin. In a connective tissue, we have only three types of proteins: collagen, reticular, and elastic. Whereas epithelial tissue was classified by the shape of the cells, connective tissue is classified by the amount of each of these fibers it contains. We're going to call these proteins fibers. There's one more component of a connective tissue, and that's the goo, or the water, in which the jello proteins are dissolved. In our jello mold analogy, the water would be what is called the ground substance of a connective tissue. It's like the background goo. Sometimes, though, this doesn't have to be gooey or watery. Sometimes it can be a hardened substance like bone. When we consider tissues from here on out, we're going to use this term matrix. This term combines the protein fibers and the ground substance and lets us think of a connective tissue as specialized cells and then the background substance in which the cells are suspended. So you're going to see this term, matrix, and I want you to be aware that it refers to both the ground substance and the fibers together. That jello mold kind of looks gross. These are our three dense connective tissues. Dense because the protein fibers are closely or densely packed together. Before we look at each one of these in detail, even though this is an online class, I strongly encourage you to make index cards if that's your thing, like you just might do to study for an in-person class. It's the process of writing them, consolidating the information, drawing the tissue with your colored pencils that will solidify the tissue in your mind. Even if you never use the cards, that process of making the info flow from your brain and out your hand is very important. It's like practicing piano. You can know the music, but you have to let the music flow from the brain to the hands. And to get better at it, you have to practice, just like the piano. The first dense tissue is it's just called dense regular tissue. Where is this in the body? Ligaments that attach bone to bone and tendons that attach muscle to bone. Think of a rope that you pull tight from both ends, and that's a tendon or a ligament. So these pink collagen fibers are all arranged in the same direction, like the fibers in a rope to take that pulling tension. You can see the darkly stained nuclei squished between the fibers. Take a look at this picture over here on the right. I just want to point that one out. Yeah, take a look at the picture on the right. It's at a very high magnification, showing you these aspects, the packed collagen and the nuclei. The picture on the left is really kind of awesome, and it shows you a river of dense connective tissue sandwiched between muscle, which is the reddish tissue kind of at the top of the bottom. There are other associations of tendons and ligaments in the picture, and this is probably located at a joint like the elbow or the knee or something that has lots of tendons and ligaments. It's just my assumption. The name of this tissue makes much more sense to us after covering the dense regular tissue from the previous slide. This tissue, called dense irregular CT, has collagen in it, but the collagen is in all different directions. The picture on the top left shows you a really high magnification, and you can see the nuclei squished among the collagen fibers. All right, so collagen is a protein that binds water. And when we make tissue preparations for slides, the water in the tissue evaporates as we dry out the tissue. And this creates tears in the tissue, and then those tears get pictured in the slide. And that's what these white spaces are. Some students think that these spaces are lumina, singular lumen, or open spaces. No, it's not an open space that exists in your body. The white spaces are something that happen as we make a slide of the tissue. All right, so let's make a connection to where this tissue is in your body. You have an epidermis, which is like a hard candy coating on the outside of your body. Many of us are familiar with the epidermis as part of the skin, but the epidermis is attached to a gelatinous body stocking that covers your flesh. This is like maybe a soft layer of fudge under the candy coating. The body stocking is called the dermis, and it's made of dense, irregular connective tissue. It's like a gooey coating between your muscles and your epidermis. Dense, irregular connective tissue has a lot of collagen, and thus it holds a lot of water. In fact, the maintenance of your collagen in your skin throughout your lifetime will prevent wrinkles. Wrinkles occur from the breakdown of collagen bundles. So use lotion and drink water. All right, it's at this point that students start to realize that there are certain structures that they're consistently seeing in tissues, like blood vessels. It's good to take a moment when you look at a tissue and kind of identify structures if they're present. They can be distracting when you want to focus on a tissue in the background. So this picture on the right, it points out some of those things, blood vessels versus nuclei. Elastic tissue is the third of the dense connective tissues. I like this picture on the top right because it looks like a tube top to me. Make the connection. This is because this tissue, as indicated by its name, it has a lot of densely packed elastic fibers instead of the collagen fibers of the other two dense connective tissues. Elastic fibers stain very darkly as opposed to the pink collagen fibers. But the elastic fibers here, they are also densely packed together. The picture on the bottom right it's at a higher magnification, showing you the squiggly nature of the elastic fibers. Yeah. Think of their name, elastic. They can stretch and reform back into their squiggly line. What's on the left here? A black hole. Kidding. It's an arteriole. What's an arteriole? It's smaller than an artery and bigger than a capillary. Arteriole is usually an unfamiliar word to students. Artery is usually what you go for. This picture at first glance, it's definitely a different color than the pinkish stain that we've been seeing. Yes, it is a different stain. First, let's identify something kind of obvious. This arteriole is a tube through which blood flows, and you can see the red blood cells in the lumen of the arteriole. Around the lumen is a very thin layer of simple squamous. You cannot see that at this magnification, but it's there. Just outside that, or superficial to the simple squamous layer, is one of those dark, squiggly elastic fibers. Yes, actually there are a few, but again, you can't really see them at this magnification. The elastic connective tissue allows the arteriole to stretch and contract according to blood pressure. Do you see that there are more of them around the arteriole? They're embedded in a muscle layer, the elastic fibers. They're embedded in a muscle layer, which is blue, because again, the stain is different.